Hello everyone, this is Yili. Today we're going to talk about a 97th question on Leetcode, increasing order search tree. Given a tree, rearrange the tree in order so that the leftmost node in the tree is now the root of the tree, and every node has no left child and only one right child. So given a tree on left, so how can we do an in-order traversal? I remember that in my class, my professor told me that what we're going to do is that we're going to draw a stick for each node. And then the so-called in-order traversal is just like we start from the left and then touch each end of the stick. The order for we touch it is the in-order traversal. So this one would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this will give us the tree on the right. So how are we going to do these problems? So there are two approaches. The first approach is a recursive approach for in-order binary tree traversal. In fact, there is a question on Leetcode, the 94th question, is about how to do this recursively. But what we're going to do today is that we're going to do this in an iterative approach. So we will do this with the help of a stack. The stack is the first in, last out data structure of file. So the procedures will be like this. When we have a node, we push all left children to the stack. So this one we have a 5 as a root. We're going to push 3, which is the left child of 5, 2, which is the left child of 3, and 1 is left child of 2 on the stack until it doesn't have any left child. And then we pop. So we got a node 1. On this stage, we're going to check if it has a right child. I'll put yes. What we're going to do is like, we're going to push right child. Let's call it C. And all left children of C. All left descendants. And that's a yes. And if it's a no, we're going to continue popping again. So when pop 1, okay, try this at 1, it doesn't have a right child. And then we pop up 2. It doesn't have a right child. And then we pop up 3. It does have a right child. So we're going to push 4 on the stack. But 4 doesn't have any left child, so we stop there. And then we're going to pop up 4. Doesn't have any right child, a right child, and then we pop up 5. 5 has a right child, that's 6. 6 doesn't have any left child, so we stop there. And then we keep popping. 6, 6, just 6. And 6 has a right child, so we're going to write 8 here. And 8 has a left child, which would be 7. Then we pop up 7. Seven doesn't have any left child, so we're going to pop up 8. 8 has a right child, so we're going to push 9 here. And then we pop 9 out. So now we have an in-order traversal. What we'll do is that we construct this as a tree, the question asked, and we're done. So what's the space complexity? Since we use a stack, the space complexity should be orphan. And what will be a time complexity? Because we only go through each node once, so we'll still be orphan. Okay, so let's try to do the question together. First, we're gonna check edge cases. If this equal to null, root equal to null, we just return null. We don't need to do anything else. Otherwise, we're gonna initialize several things. First is a stack. And then we're going to initialize the tree node head as the return node. Actually, not initialize, just get a placeholder. And current equal to null. And tree node temp equal to root. While temp is not equal to null, we're going to push temp to a stack, and then temp equal to temp dot left. So all its left descendants will be on stack after this step. And then we'll check if the stack is empty. If it's not empty, what we're gonna do is that step 1, we're gonna pop equal to a dot pop. And then if this is the first time we pop this stuff, so head equal to null, we're gonna set head equal to new tree node. And then temp2 dot value, and then current equal to head. If this is not the first time, then our current right should equal to new tree node temp2 dot val, and then current equal to current dot right. And then we're going to check this temp2 if temp2 dot right child is now equal to null. First, we're going to push the right child to the stack, and then we're gonna set temp2 equal to temp2 dot right, while temp2 dot left is now equal to null. And what we're gonna do is we're gonna push temp2 dot left on stack, and then temp2 equal to temp2 dot left. So all its left descendants will be on stack after the step. Yeah, that should do the trick. And then finally, we're going to return the head node. Let's see how this thing goes. First run the program. Yeah, looks right. Submit again. Yay, we did it. That's it. Hope you enjoyed this video.